Okay, hello, welcome back to devlog with kottefolket with me, Lumarsenil. Woohoo! Let's continue here. So yeah, last time we just got back to the project and made some changes. So I updated to Zig 0.16. Yo, good morning, Micon. What's up? Welcome back. How you doing? Are you ready for Raylib 6.0? Oh, Raylib has also updated, I see. I have not checked that out. I'm not sure what version the bindings are. I mean, I guess it's the earlier version. Yeah, it's 5.6. And what is... Okay, so it's... Yeah. I'm not sure... Well, I mean, I guess since it's a C library, we can just import it directly. Although the entire project is very much like using the bindings. So we would have to wait for the bindings library to update. Master's already 6. Oh. I wonder if there is a... Maybe there's a branch actually for... For Raylib 6. I don't know. Maybe not. Doesn't look like it. I mean, I guess we could migrate, but it's so ingrained into the project right now, the bindings. So... Wait, is it actually ingrained in the project? Now that I think about it. Because I mostly use my own vectors and then only use Raylib for like rendering, music, or not even music, like sound. Build.zig is done for Zig. Okay, so cool. So Raylib 6. Let's see. I might migrate to the C library. It's just that the bindings does have a pretty nice like zigifying some of the types and stuff. So it's a little bit better, I would say, to run the bindings. But then again, is it really necessary? Because I'm not really using Raylib that much. It's mostly been like abstracted, I guess you could say. So that's the question. Because yeah, that would be the best probably to get rid of the bindings in that case. Wait, no, this is the bindings. Yeah. And so here's the actual Raylib. And this is... So this is version 6. Okay. So I could essentially just go for this. What, Xcode? Okay. Yeah, the bindings will update it. Yeah, okay, so if the bindings... I'll probably not do anything right now. If it gets to it, like, what I could do is check out what are the differences. Wiki. What's the change log? Okay. A lot of changes here. Key changes. New software render backend. RLSW. Software render. Okay. New platform backend, memory buffer. New platform backend, Win32 experimental. Memory, Win32, AppScript. Okay. Redesigned full screen modes and high DPI content scaling. Cool. Redesigned skeletal animation system. I didn't even know that it had one, to be honest. Because I'm not doing much of that. Build config system. New file system API. New text management API. New tool, Raylib examples manager. Added 50 plus new examples. Okay, cool. Text management API. Interesting. What I would like to do actually is, because I noticed my editor has a lot of dependencies right now, all of which doesn't work with 0.16. And that was kind of annoying. And other things that are annoying with that is also like the Ingui versions, which doesn't really match up with the newest version or whatever. It has like an entirely different API. There's things missing and stuff like that. So I might do something else there. Try to look for something that is, I guess, more maintained maybe. Because I basically hacked together a bunch of different libraries that happened to work with the latest Zig at the time, but now I'm not so sure if any one of those are ever gonna be upgraded. I don't know. So or just try to just use, because the thing that I'm using is I'm trying to use like Raylib together with Imgui, and yeah, that's the thing. Like, and then there's like a library that integrates them and stuff like that. But anyway, cool. I'm not sure if this is like enough for me to actually like try to hurry up and use this. But yeah, that's cool. I'll have a look at some of the examples maybe to see, okay, what can you do with this new stuff. Cool. Thanks for telling me. I didn't know that they were making new versions right now, or that a major version there. I only use Zig and ZLS. What, in what respect do you mean? All right. Probably not. But they changed a lot in the build. Let's see. Okay. As an extension of the IDE. Okay. Well, yeah. I might check out the examples to see like what new features are there. Is there anything that I'm super interested in? But I'm gonna probably put that off for now until maybe the bindings does get an upgrade. We can just upgrade painlessly there. But yeah, the editor, I would like to kind of explore maybe other things. Maybe start to kind of abstract the UI part so that I can like switch out the backend, maybe something like that, and then even like try to make my own backend, or just find something that is that works better. I don't know, or just find a replacement for like the Raylib stuff, because I think the only thing I'm using Raylib for is essentially just the image part, like drawing images. So if I can just find something else that will do that, I mean, that's obviously very doable. I mean, even Imgui can do that, I believe. So I don't really need the Raylib. It was just that since I was using Raylib for the game, it made sense to use it for the editor to kind of have the same API to be used there. But yeah, I think that do away with the Raylib integration there will make it a lot less complicated setup, and I'm possibly even removing my weird layer that is like was meant to be some kind of experiment, like the ZXG, I think I was calling it, or something. I don't remember. But anyway, enough of that. Why not use SDL straight? Well, I think the problem is that it has to the only issue is that on the editor part, like it has to integrate with Imgui or Imgui or whatever it's pronounced. That's the only thing. Like Imgui is like essential for showing the UI and building the UI, and then sometimes you want to draw a picture. Then I use Raylib, but you know, I could probably just use, you know, Imgui or something else for that. But okay, so let's see. Yeah, so back to this. So yesterday we made a whole bunch of changes. So the project now, the game is updated to Zig 0.16, and well, the everything and all the libraries and all that work with 0.16. I think I'm not sure if I had to upgrade some of this. Yeah, ztrace, I think I had to modify a tiny bit. Yeah, that's right. We got ztrace to work yesterday, that's right, with some elbow grease, and so we can profile what is going on. However, after some changes here, oh yeah, that's right, we implemented my first multi-threading in the game, actually in the physics engine. So the physics engine now uses the new IO stuff for the collision detection system, because there's a section in the collision detection system that we basically can parallelize a bunch of calculations. So we basically spawn up a bunch of threads to parallelize this stuff. Hello, learn with Rai. What's up? Hello, welcome. Let's see. One second here. Yeah. What are you working on? I'm working on my metroidvania game. Actually, I can probably just show you real quick here. If it shows up here. Wait, no, this is the... Wait, what's the build error? Oh. Okay. I get a seg fault right now, so I can't show you, unfortunately. But I am working on it, and it can't start right now. But well, I mean, I should have a working version here. Whoops. Wait, no, this is the thing that fails, right? Yeah. Sorry, I don't have a working version right now. But it's essentially 2D side-scrolling, you know, sort of like if you played like Hollow Knight. Not really exactly like Hollow Knight, but kind of similar. Think like, I don't know, Castlevania 2, Zelda 2, side-scrolling. You go around with the person who has like a close range attack and kills monsters, finds items, upgrades, and all that. All right. So anyway, so we have this problem. We did this yesterday. So basically, what we're doing right now is we create a new type of thing that is new in 0.16, which is called a group. Now the group is in IO, and the group is essentially just a collection of you can spawn async tasks in the group. So this will essentially, since IO is like it's a threaded IO, it will spawn new threads. As far as I can tell, it uses some kind of pooling system. So it will spawn this. It will run this function in a new thread and give these arguments here, and then this will spawn up. I think I have 10 threads here. So this will divide the work in 10 threads. Actually, might be +1 because there's like a division going on here. So we might have more number of threads +1. So 10 or 11, depending on how many entries we have, how many like entities we have. But 10 or 11 threads are spawned up here into the group. And then you can say group.await down here. So then this will wait until all these are done, basically. And then these are like, we're sectioning off each call here with different sections of these buffers here. What new Vim theme is this? This is called Melange, or like this. Well, the color scheme is called that. There you go. Wait. It looks good. Yeah, I really like. I like the look of this this color scheme here. And I've got used to it now as well because I've been using Zig. I have like different color schemes based on which language that I've opened. So for Zig, it's Melange, and for TypeScript, it's like, I think it's like Tokyo Night. No, actually, I think it's like the default VS Code theme I have for that because I'm so used to that. Anyway, yeah. So, but there's something wrong going on. There's something going on here which crashes the whole thing, I believe. So if we'll take a look at the error message here, we get a seg fault, and it happens somewhere. What the hell is this compiler? Compiler RT. Threaded. Yeah, there's something going on here at least. Hang on, 447. Oh. Yeah, I've also make sure that this allocator is thread safe. So that's why we're allocating stuff in here. Now, I'm wondering if we should try to not do that. So we're using essentially this as a buffer. But maybe we should like do it before we send in the buffer to we send in the buffer. That can be reused the same way here instead of allocating it here. As far as I can tell, this should be possible to do, but okay, I'll just send in a usable buffer here, which is gonna be one for each thread then. And it's gonna have this size. Okay. And then we can also free that. Okay. So instead of doing this, the buffer will just be, wait, this. Okay, so essentially what this is we are allocating the like space for all potential intersections that could happen for this thread, which is like how many entries per thread times the total number of entries. We send that in here. This is then being used over here as a buffer to be able to populate a new, like a dynamic list here, and then this list turned into a slice. It's moved into a new location. We store it in the result slice. Now this one has all of the maps, basically from it's mapping entities to number, like a slice of intersections. Okay, so now we don't have an allocation happening in here. pretty sure. Except we are putting an allocator in here. However, yeah, that's still gonna do stuff with the allocator, but Actually, you know what? We don't really need to move the thing. We can simply just keep... We don't actually need to, like, remove this. We could just keep it around, perhaps. We would need to do, like, a pass later, then. So this would essentially... It would be, like, items. This will never, like, do anything. This allocator, it won't ever be used. But we need to pass it anyway here. Okay, so then... what we do is we do this, but we also want to... Actually, this is stupid. I can't free it in here. Oh my god. Okay. We have to like create one for everything. So this is gonna be like basically entry squared. If you have 100 entries, there will be 10,000 entries, and each entry is like, I mean, it's like 300 bits. $40 bytes, let's say 40 bytes, 400 kilobytes. I mean, it's not that big of a deal. We're probably gonna have more than 100 entries, but whatever. Let's just see here. So we'll have this buffer. This buffer will be also sliced off. Now what would this be though? This would be like entries per thread times, so it's like offset times that. I think, yeah. So it will be this length. No, wait, that's not correct. No, yeah, that's it. That's correct. No, it's not correct. Wait, no, it's entries per thread. So that might be, I don't know, 10 or something times t, which is the thread number. And then, so that's the offset. And then we need to times that by this, because this is times this. Okay, and then this is gonna be, so the length of one of this is what I need to calculate. Intersection length is gonna be entries per thread times entries items length. That's the length of one of those. So this one essentially be the length times t. That's what that's gonna be. And then this is the offset plus the length. Yeah. Right. So there we go. And then you will still need to be calculated here. This is the buffer length. Buffer length with that. Yeah. And then this is set to the collapsed slice here. And that's gonna contain everything in the end. This, but then we need to, so after the await, what we're gonna do allocator free intersection buffer after the whole thing. But down here, we're gonna go through all of the intersections. Oh, we already have them here. Okay, so we don't free, we just call intersection. Okay, yeah. We don't actually need to keep this around. We just, there we go. Okay. I'm not sure if it comes through here what I'm trying to do, but I'm trying to make it so that when we're in the thread, we don't really allocate anything. And hopefully that will solve the issue. I don't think it will, because this looks like it's crashing right now. Why is it taking so long? Also, what we could do is instead of having this be allocated every time we want to do this, we move it to a common. I mean, this is what we had before, actually. To be honest, like we had a common place where we put the intersection buffer. It's just that everything could access it willy-nilly. So I think what I'll do is I'll put it here. Well, we already have it here. So we'll have this one over here. We're getting it back here. But what the idea of what it was supposed to be used for was like only like one of the temporary buffers. Now it's used for every intersection that could happen at every frame. So I think what we'll do is like initial entries capacity times initial. So it's gonna be a capacity like entries times or squared, I mean, which is around 3,000, yeah. 3,000 squared is, wait, no. Yes, 3,000 squared is 9 million times 40 bytes. 360 megabytes. That's a little bit more. Okay, whatever. Now reset. Okay, that retains capacity. Good. Deinitialize is deinitialize. I don't think we're deinitializing the thing. We're keeping this thing around. I'm pretty sure. We're not doing anything like this. Now what we will want to do is here. So this one we still want. The thing is here, what we will want to do is we want to say intersections what is this? Oh. And we want to ensure capacity is going to be that. Are you canceling the IO defer for the group? No, I'm not canceling anything. Infinity loop, yeah, it felt like that. Hello Mutasemos, welcome back. Ignore these catch-all rituals. I've explained why I've had those. It's fine. It's only gonna happen if we're out of memory. Okay, so there we go. So we got that there. Now we don't do this. We could like we could like say clear retain capacity if we want. We could also not do that, because I think we want to have it around, the data around, I think. Okay, now it crashes at least. Doesn't hang. Index out of bounds. Really? Oh, I see. Right. Because it's a... right. So we don't ensure total capacity. Okay. What is the thing called? It's like... it's a thing where... is it resize? Okay, this is the one we want to use. Resize. Because we want the... we're basically creating a buffer. If you just do the other one, if you just do like ensure total capacity, that only affects the capacity, which means that it has an allocated space for that many, but the list itself only looks at a slice of that allocated space. So resize will actually say that, okay, well, our actual list is now this size, which means that we can have like undefined values in the list because we haven't populated it yet. So it's essentially just like when you do like a new array, you set it to undefined and then you populate it later. So this is what I want to have for this one here. Okay, let's try this one now. Resize. Oh wait, allocate. Okay. Yeah, so I'm not canceling the group. I'm doing like an await over here. There's nothing here that will exit this control flow here. So or code flow or whatever. But okay, what happened now? Index out of bound length 10,000. But this seems way out of bounds. 409,000. We could log out these numbers. It should only happen like immediately, so it would yeah. Let's log out like length. Buff. Oh, what the hell are these names actually? It's sections. Buffer length. Buffer offset. There we go. Wait, that's the first one. It has 409,000 length? That doesn't make sense. We don't have 409,000 entries. Wait, how many entries do we have then? Entries per thread is 10. 40,000 entries. Wow, do we have that many entries? Okay, and what is the buffer length? $10,000? What? I thought they would have the same length. This doesn't make sense. Also, this doesn't look like 40,000 entries, although there might be more. Holy crap. 40,000 entries. Yeah, that doesn't look correct. If you finish the group, you need to cancel, no? But we're calling a wait here. I would assume that after this, you don't need to do anything, basically. It blocks until all tasks of the group finish. During this time, cancellation requests propagate to all members of the group and will also cause cancel to be returned when the group does ultimately finish. So if something would like to cancel while we wait, it will be propagated to everything. But I don't think that's happening. Like the tasks are simply finishing, and then this will just wait until all the tasks are finished. That's how I'm interpreting this. It's not thread safe. The hell does that mean? It is safe to call this function concurrently, group async or group concurrent, provided the group does not complete until the call async. Well, we're calling it from the main thread, so I don't think it's an issue. Also, what does idempotent mean? Idempotent. I mean, I've probably read it like 1,000 times, but I can never remember what it means. Describes an operation, function, or element that produces the same result, regardless how many times it's applied after the initial application. Okay. So it's like if you can call this again, and that won't do anything, basically. Yeah, it makes sense because all the tasks are now done. You call it again, everything is already done, so it won't do anything and just keep going immediately. It's so hot in Bangladesh, really? I mean, even we got some nice bright sun right now. It's like the first bright sun since autumn. How many degrees where you are right now, Mutasimus? Okay, we'll do this. We will go to main here. And I will remove this part, because that is like adding more bodies, more and more bodies until we get lag. Now instead we... What the hell? Let's see. Why is it still so large? Buffer length is... Maybe is that this is the initial, maybe 3000 times 3000 is 9 million times like 300, 2.7 million bits, and this is like 100 million bytes, 100 megabytes. That seems too large. Maybe I miscalculated something here. 32 degrees. Whoa, shoot. Does it, I mean, I guess it only gets hotter when it goes over to summer, right? Tropical country, yeah. Humidity 59%. Excessive heat. So everyone has like ACs at home or something like that? Alright, so 1 second here. Alright, there we go. Yes. Yeah. We just have a couple of fans. That's all we need here. When it gets hotter, like it's not even required right now, but in the summer it can get like around, I guess, what you have now. So that's insane. Okay, but anyway, this I think this means, no, this is how many intersections there are. It's like 100 million. How is this? Oh, because there's 10. How can there be 10,000 entries? I'm confused. Oh, now we got a segfault. Also, why do we get like length 0, offset 0, and 0? What? So okay. Yeah, I'm thoroughly confused. These two should be the same, but they're not. One. So that makes more sense. Why are there 10,000 entries? That does not make sense at all. We get one entry in here. We're copying over the things. Oh, wait, this is a buffer, right? I see. This is pre. Okay, I see. I see. So this is this is primed here. Okay. Where is it primed though? Is it primed in this one maybe? Yeah. Here we go. This is primed here. Okay. And entries, I don't. Yeah, okay. So the thing we should use is the entry values. Right. And where is the thing? So actually, this would be entry values squared which is interesting. Also, if there's only one, we can't get any. We actually can't get any intersections, although there would be, this will still be one here. But okay. So there we go. And then yeah. But this would essentially be 0 because we have like less number of entities than threads. So it's like if I think what we need to do is we need to take the minimum of number of threads and well, actually we are kind of already doing a check here. So maybe, but this one here is like not really correct. I think no max. So if this goes to 0, we actually want 1 here. We're at least 1 per thread. When you start running in Snake, it's hard to look back at cameras. Yeah. I I gave in to the snake case. I used to do only like a camel case for all the variables and fields, but then someone was like, hey, that's not canonical zig, and I was like, F you. I don't care, like I wanna write what I wanna write. But then I was like, well, there is actually a practical value in switching it up, because sometimes you have a function that has the same name as a variable, and then it's because of the shadowing restrictions you can't actually have them the same name. So then it becomes actually it becomes a practical thing as well. So I actually did get used to that. So I've gave in to the snake case for so essentially it's snake case for variables and fields, and then camel case for functions, and then Pascal for types. This I'm not sure if this is canonical. This is just constants, but I don't know. I'm not sure. Like, it kind of is kind of special. This thing here. I'm not sure. What is this called? Scream case or caps case? I don't know. Okay. Length. And so the intersections length. I want to say, let's do this. Let's calculate the length of this. This is going to be entries per thread. However, if yeah, that's the thing. But then this could meet the end before as well, so we would need to do right, and we'd never take entries. We always now take length. So I would like to say that number of entries is going to be entry values length. Okay. I'm gonna move this over here. And yeah. Okay, and then over here. This is wrong. There we go. Okay. Cool. Let's remove these so that we don't get spammed here. Okay. It works up until some point here. Adding world save dependent world generator to my game, so it will be better than Minecraft because your worlds will actually not break in chunk error. A world save dependent world generator. Oh, cool. There's so much that goes on, goes into making that kind of game. That if you play it, you just take it for granted almost. I mean, yeah, that's for like all games basically, but container 269 quadri4 for this intersection handler, I believe. Yeah. See if we can get something out of this. It's like when I add enough of these, maybe when it starts to go over the number of threads or something like that. So let's see here. Offset 0. So this will be a new frame or calculation here. So we got 121 buffer length. So that's like the number of entries squared, which makes sense because it's 11 entries. Entries per thread is 1. Okay, that also makes sense because there's only 11 entries and there's like 10 threads, which almost makes it, is it worth it to spawn 10 threads, 1 thread per entry? Probably not, but then there's probably not that much work anyway, so it probably will go by pretty fast anyway, but probably we want to have something like that when there's like, or maybe it doesn't matter when there's so low number of entries that that doesn't matter. Like maybe, yeah. But anyway, that's not the thing. We want to see what happens, why it's crashing right now. So length is the length of the intersections buffer, which is 11. Is that correct? 11. I don't think so. The length is entries per thread is 1 times number of entries. Okay, I guess that is correct. Yeah, okay, so that is correct. Okay. Offset 0 because it's the first one. End is 11. Makes sense. Then we have the next one. So same thing, everything is the same except the offset and end. Start at 11 now and end at 22. Okay. Buffer length is 121. So essentially if we go up to 121 and then we're done and then we restart. Now we have 12 entries. And that's where things go wrong, I guess. Offset 132. Alright, I need to BRB 1 second here. Alright, sorry, I'm back. Yeah, sorry, Mutasimas. I did say I was gonna BRB, but maybe I was too quick. Alright. So why is this like this? Why are you like this? And this intersection handler, are you then copying this stuff? We don't really care about this. Yeah, we're doing other stuff with this, so we don't really care about this slice. Could it be that one of them is not like is like one of them or is not initialized properly, so it's like some weird slice information there that is not proper. We allocate it here. Maybe we should loop through and initialize everything to 0. That could be what's happening. Might be the thing that's happening. Okay, that seems a lot better. Let's get rid of these logs here, because that might be lagging the whole thing down. Okay, yeah, this feels a lot better. Cool. Now let's go back to enabling the thing we had before, debug. This one, which will automatically add a bunch of bodies until we start to lag. There we go. I think it looks like we have more than we used to. A little bit, at least. And let's see, because it should log out like how many we have. 400. That's not really a lot, but okay. Anyway, hopefully this will solve the issue so that now we can run the game. Building, and there we go. Cool. Now let's go over to see if this problem was solved over here. Okay, cool. So that doesn't crash anymore. Right. Very nice. Now the ultimate test. what I was gonna wanna do was that I was gonna wanna enable the profiling to see how much of a difference this makes. So, but we'll do one test here. We'll do a test for the gems. And by the way, here's the game if anyone who was interested in seeing what it looked like. And okay, so here's the chest. Now what happened before is that before we did like the upgrade to the system, the physics system, was that when you open a chest, there's like 30 gems being spawned. That's gonna happen now as well, but it used to lag a lot. We'll see how much it lags now. Okay, so it still does lag quite a bit. That is unfortunate. But I do believe we've made a little bit of improvement, but let's run with profiling now. And I will find my profiling program wherever I have it. Okay. For some reason, when I open that, the game, like OBS doesn't like show the game for some reason. But now let's go back over here. So over here we get some lag because now we're profiling. And let's take a sample here. That should be enough. And I want to quit the game so that I don't mess anything up here. And let's just go over to one of these over here. Right. So I think there is a huge actually improvement, since before we had like multiple physics update in one frame, but now we have like a bunch. Now this seems to happen way faster. It's like, I think we've like halved the amount of time the physics update takes, which is really nice. So let's go in here and see we can only see the main thread. I wonder, because we do have zones in the threads as well, so I'm not sure why we're not seeing those. Like, how can we enable that? I don't know. Flame. Should be like below here. Well, I guess this one is yeah, this is the one. But it's happening in like separate threads. Hello, Round Naxrar. What's up? You like C++? Cool. What do you like about it? I like Zig. Okay, so what is happening here? Like, why can't I see other threads here? Do I have to... Do I have to like mark those in some way, or? Maybe I need to look at other things over here. Okay, I see. Here are there a lot of these things going on in parallel as well. Oh, I see. So it's like it's not really visible until you go like this. Interesting. I wonder why it stops over here. Like, why can't we see anything like beyond? Like over here it just disappears. Maybe it didn't have time to collect all the data. I don't know. But yeah, here we can see a whole bunch of these being spawned and stuff. The question is, do we have additional stack frames? May have been skipped. All right. Wait, no, that's a memory leak. Yeah. No, what I wanted to check, I want to check the zone. Maybe we want a zone for each of these as well. Maybe, I don't know. Probably not gonna be that much. I mean, it's gonna be the logic happening in here. That's gonna include because I want to include like the time it takes to spawn an actual thread, and then possibly something over here, which is how much time does it take to wait for this whole thing. So this would be thread zone. It doesn't really matter what it's like. It's gonna be in context, so we can name it like this. That's fine. And then over here we'll have the await group await. And let's discard this. Start up again. Go over here. Wait, I did the wrong thing. I need to start up like this to get the profiling. I was like, this can't be right. It doesn't lag. Now, there we go. Let's let it settle a little bit. And we will connect. Stop. And okay, now we get a little bit more things happening in here. So these spawns actually does take like, I mean, they take a while actually. The spawns themselves. Like if this was just taking, if this took like way less time, this whole thing would go way faster. But this spawning, yeah, there's a lot of time going into actually spawning here. And then if we go to these, we can see that each one takes like 177, but that's parallelized, so around 100, sometimes a little bit more, 100 to 200. And yeah, it's insane. It takes like as long as so we wouldn't actually gain anything from spawning this thread here than just running the logic directly in the main thread. It takes just as long to spawn the thread than to do the actual calculation. Actually, it takes longer. Like this one is faster than this spawn thread here. That's insane. Because that's what I was thinking. Like, it feels like spawning a thread takes time. That was saying before, like last time as well. Spawning a thread does take time, so that's why I was thinking like keeping like a pool of threads ready to go, and then just assign some work to one of the threads. If that can work faster, maybe it will be worth it. But this, I mean, I think we've gained maybe something from this, maybe. If we have a lot of entities, possibly. Okay, so what I'll do is I will save this here. And I'll call it multi-threaded. And then I will discard. And now I want to go over to the dreaded chest to open it and record the lag that is happening. Also, the quad tree has like a major flaw right now. If a like there's such a thing that called orphaning. So if something is like on the center line of the quad, which is this blue line here, if I'm going up to the center line, that is now I'm orphaned basically, which means that I basically need to brute force check against other. Like every orphaned entity needs to be brute checked, I guess, because we can't determine exactly where, in relation to other quadrants, where we are. So also like, or it might be that I'm both like I'm in both quadrants, so I have to check both. Or we can also be like in the center. As well. Okay, but now is the moment of truth there. So let's start. Let's connect here. Oh my god. Why is this happening? Okay, I'll try to restart this one. No. Okay, I have to actually restart the whole thing. So it seems like you can only, for some reason, you can only connect one time. And once you've connected and disconnected, then you can't connect again for some reason. I'm not sure if I'm doing something wrong with my setup, but yeah, it's a little bit unfortunate. Let's just try to get back there and we'll record things happening. Like I can still play fine. Like there's no input lag. Even though it's like lagging like graphically. The sound still plays fine. So that's good. Okay, here we are. Now let me enable this, connect, and I'll open the thing, and then we'll stop. I'm not sure if this gets recorded properly because it's like it's stopping at this point. Like I still don't understand what is happening over here. Because to me this feels like how much time has passed. Like why is it bunched up like this over here and over here we get nothing? Because now we don't really see what's going on at this stage. That's over here. I want to see what's going on over here, not like over here. Maybe I needed to have it run longer. I don't know. Okay, let's see if the last frames here were taking longer. No, they didn't. Okay. Because I wanted to see what is actually taking time. What if we reconnect? Try to reconnect. Probably doesn't work. No. Okay, I'm gonna try this again here. And oh, what happened now? We got a crash. Unreachable code. Player 734. What? Oh. Interesting. So there might be a crash related to maybe transitioning while having missed form on. If I press a button, I get like enter this mist. I'm doing this mist ability. If I do it in a transition, I guess it crashes because it can't. I'm not properly restoring the state there. So that's a bug. And if you're wondering why it lags, it's because we're running with a profiler right now, so that everything takes longer, so that's why that is happening. Okay, is this the place? Yeah. Oh, but surprisingly, it still feels like you can still play it like this. There's no input lag. I say as I missed this jump here. It's a little bit disorienting with the lag when you're like graphically, but other than that, it actually, you know, does what I tell it to do. Okay, so here we go. I'm gonna connect, open the chest, move over a little bit. I'm gonna have it run here for a little bit. Maybe we can pause. See, it is collecting the information here. So I will just have it collect all this information. And we can now see maybe what's going on. Hello, Nutslider, welcome back. Long time no see. Did you create the art yourself? Yes. The beautiful 2D art, pixel art. Tracy. Yes, so we're using Tracy here for profiling. I have set up zones in my physics engine and the frames in the game. So it's currently collecting all this data here. So hopefully we'll be able to... Oh shit, is it crashing right now? Okay, the game crashed. Hopefully we got the data we needed. Oh no! The profiler crashed as well. Man. Okay. Thank you, Polaris, finally, for the follow. Have a nice day yourself. Okay, so... I mean, what we also could do is we could go to our test program here, and we can disable this. What we can do here is we could simulate the same kind of setup, perhaps. So let us do that. So essentially what's happening is we just need to spawn a bunch of things in kind of the same spot. So essentially we want to do this. So let's do a rectangle. X, wait, position. Oh, that's just one. Right. So let's do, I don't know, 30. And they're essentially going to be sort of in the same place. They can essentially be in exactly the same place. It doesn't really matter. And yeah, so we actually don't really care about this. Now, if we run this, will it kind of lag right now? Oh, that's the ground. Well, let's make them maybe smaller. Sort of, I don't know, 3 by 3. What happened to your language dev? Yeah, so I went back to my game dev project, and the runic the runic language is still, you know, technically you could say still kind of active, although I'm not spending too much time on it right now. But I did reach kind of like a MVP version that I was happy with. So there you go. It has like a bunch of features, but I did notice some features were kind of lacking. If you want to have like there was a thing where you want to call a program that exists that's not like in path, but it's like in a directory or something like that. You can't actually do that right now unless you're you could call bash to do it, but you can't type like, you know, scripts / my script and then call that as an executable. So I have to figure out how to solve that issue. And then not only that, but also if you have like an executable maybe with some special characters, or I don't know, some weird stuff like that, like with spaces in it or something like that, then you can't really call that either. So I have to figure out a way to do that. But and then there's like a bunch of other stuff that I want to add to the language over time, but I'm not spending like too much time on it. It's probably gonna be like, if anyone else wants to contribute, I'm open to that, and I'm like actively maintaining it for that. But but I will probably only work on it myself if I start to use it more and, you know, encounter things like, oh, this would be nice, and then just add that over, and, you know, stuff like that. So it's still active, but it's not like the main focus on stream anymore, because I want to get back to making my game here. Okay. So it doesn't really lag the same way that the game does. Let's up the number of rectangles here. I want to check something actually. I want to check when we pick up items, which code is responsible for checking intersections? Is it the player or is it the item? Because if it's the item, we have a whole bunch of checks going on in that case. No, I'm pretty sure it's pickup. Yeah. This is the thing. pickup. So we have the pickup system. No, we only do one intersection, and then we look at all of the intersections found. Right. Excuse me. So I don't think this is because this only happens once per frame, so I don't think this will actually do much of anything. Because we have like 30 items. It won't do this 30 times, it just does it once. So okay. I mean, I could try to be kind of faster. I could try to set up the situation, be faster. I mean, the reason why I'm trying to do other things is because this seems to not really make a huge difference here. Actually, what is the last thing? The last thing is static. Oh, I see. Well, let's set that to false. Because the items are not static. Cool. So if we were to kind of simulate the same thing, we would also have maybe, I don't know, let's do like 50 rectangles spawned in like random places. Is this 0 to 1? Yeah. Oh yeah, sorry. So this would be like times, I don't know, 150. Actually, times 300 minus 150. And these are static. So that's kind of simulating the ground. Okay. Still get like 50 FPS. I think we have way more than 50 then. We have like maybe 200 or something. There we go. Let's increase this radius. Okay, when we run this, you can see here that these things are like on a line or something. Let's move them a little bit to the right. Wait, where are they? Oh, sorry, not, that was down. Okay, now they're in this middle here. So, but they're not really colliding with each other though, right now. Let's do, do they have a collision group? Yes, rectangles. Player, rectangles and circles. Player is colliding with the rectangles are colliding with the circles, and the rectangles are colliding with other rectangles. Because it's kind of weird, because what seems to be happening is like the game runs fine until you open the box. Like it has like a couple of 100 FPS, and then you open the box and it tanks down to like 5 FPS. What happened? And then what is happening? So what I was gonna say is that it feels like the issue with the gems spawning is less to do maybe with the algorithm and maybe more with, well, I don't know actually. I mean, the strange thing is that suddenly it just tanks down to 5 from going like 100 FPS or like 300 FPS, 500 FPS, 1000 FPS. It goes down to like 5. And then if you pick up like 20 or 25 of those gems, it suddenly goes up again. So maybe it's how we actually do the physics simulation actually, because we're trying to play catch up. That's also one thing. We're playing catch up. And maybe that's why it just tanks like that. Wait, that was strange. I ran out of memory. Segfold at 200,000. Or, well, it's hex. That's a weird address. Ran out of memory. Maybe it was like the intersections. There were too many intersections, something, I don't know. Okay. I mean, I have contemplated to just grab a physics engine, an established physics engine that already exists, but I mean, to like, it doesn't feel like it should be. I just want to be able to see what's going on. Why is, like, when we do this part, it just doesn't, the Tracy server on the, or the client is not like, it like crashes both the Tracy program and this, so I can't actually do the profiling. Okay, we can try this. Let's do let's start this up. We'll head over to the place. And I'll try to be quick. I'll try to be very quick about opening the chest and recording that. I mean, actually, to be honest, we don't actually need to time it. We can just open the chest, because it's gonna stay laggy at that point. So we can just open chest first and then connect. God damn it, I'm so stupid. Yeah, let's do that instead. All right. And I could have also, I mean, I could have also spawned over there, but whatever. Okay, so now I will open the chest. It will start to lag, and I will open my profile program. Well, it starts to lag more than it did, but yeah. And then I'll connect, and I will pause. Can you see this now? No, you can't. Here's the thing. You can see it's collecting stuff. Hopefully it will. I think we have enough, to be honest, but I just want to see. Actually, you know what? Let's stop it before it crashes. No, where did you go? Stop. Okay. Cool. So let's go down somewhere here. So here we have a frame. This does not look correct. This looks more correct over here. Yeah. I wonder why it doesn't look correct, but okay. Hopefully we can at least see why or what is taking so long. So this frame here, for example, let's see where it starts there. There somewhere. This is the entire frame. So this is 67 milliseconds. It's like, yeah, it's a lot. So we're just still doing 8 physics updates, which we have to do because of precision. Each one takes 8 milliseconds. That's like almost half of the real estate for one frame. So we would probably need this to be like decimated, basically. It's like over 10. It should be like divided by 10. That's how long it should take. It takes 10 times longer than it should. Or then you know, we would want to get down to 10% of where it is right now. Okay, so let's go in here, one of these, and see. I mean, it's just that everything just takes longer. It looks the same kind of as we had before, except everything just is scaled up, basically. I was hoping to see if we could maybe see some different different things in here to kind of understand, okay, that's where the problem is. But let's see now. Like, for example, this takes, hang on, yeah, the physics update takes like 8.63. Update collisions. No, what I'm not speaking correctly. Actually, the physics update is supposed to be 1 per frame. So maybe there is an issue. Okay, maybe there is no issue then. This physics update takes 8.63. Yeah, that's right. The previous one took 5, so it only increased by like 3 milliseconds. I think it's just because of how we update our frames. Because we're trying to squeeze all of these updates into one frame. And I mean, yeah, obviously it doesn't work. So maybe there's something wrong with our thing here. Yeah, these take like 5, the normal ones. And then something weird happens over here. This frame is like 200 milliseconds for some reason. I'm pretty sure there's some strange things with the instrumentation here. All right. So actually, we probably would be able to take this here. If we go over to the end, how does that look? It's still the same. So I don't see this as being a huge deal. It's just that the frames get longer because of how we kind of update them. Let's go to main. Here's the loop. No, that's not the loop. Here's the thing. Like, it might have something to do with this. We're playing catch up. And by doing that, it's like subsequent frames get stuck in this catch up game that we've created here. That could be what's happening. So we essentially get stuck in playing catch up, and then it never goes back. It's like we're taking a loan from the current frame and then paying it back. Well, we never really pay it back, I guess. I don't know how what the analogy would be here, but I think that could be what's happening. And then it only goes back down once, I guess, the physics update is like... Because really, the only thing happening in here... Well, there's a bunch of things happening in here, but we could make a zone here, to be honest. But really, the physics update is the thing that takes the longest. So okay, let's just look at this. So we have fixed update accumulators more than seconds per frame. Then we run a fixed update until we've caught up with the thing. The thing is, though, maybe we should have the time be slowed down. Is that the thing? Do we want the time to be slowed down? Because we wouldn't want to have like imprecise physics updates happening. Is the time just going to be slowed down? Probably. So I think what's happening is that world time is like the total time the game is like in-game time. Like how much time has the world been simulated for? It's like simulation time. Simulated DT is like how much time is gonna advance in this frame. And if we're paused, it's gonna be 0. Makes sense, right? Otherwise, it's gonna be how much time the frame actually took since last time, or whichever is lesser here. Max fixed updates per frame times seconds per frame. I think this is like 60 frames per second. No, 100. Okay. So I'm gonna test something here. I'm just gonna set this to like, I don't know, 30 or something. And then I'm gonna run it without the profiler. And see if we still get the lag. Where is the thing? There we go. Whoa, holy moly, what the hell is happening here? Okay, that seems to have messed things up. Okay, let me check something here. Frames per second is 30. That shouldn't like... That should really not mess things up like that. Seconds per frame is 1 over frames per second. So essentially, this will be... well, usually for like milliseconds, if you have 60 FPS, that's usually like 16 to... Well, usually, the calculation is basically 16.66666 infinite milliseconds. So it will be 0.016 something. This though is half of that. Actually, it will be seconds per frame will be doubled then to be 0.32 something. It's 33 maybe. I don't know. Or 0.033, sorry. So that means that this will be higher, which means that this will be higher. So the simulated, is this flawed, this here? This seems weird. F frames per second. Wait, am I thinking about this correctly here? This is lower, so this should be higher. Yeah, no, that's correct, right? So it's like 60 frames per second. So how many seconds per frame? It's 0.16 but 6666666. 30 frames per second is 0.33. So that's higher. So seconds per frame is higher. But is that the simulated DT? I guess it is. But then do we actually wait to simulate that? You know what? Actually, if, let's say, yeah, you know what? We don't actually set the game. Yeah, set target FPS. Like, we don't actually set this. So let's set that. Maybe that's the issue. Maybe. Because if we get more frames in this in a second, I mean it should still. That still seems to work properly. It's just the movement speed that seems to be affected here. That's strange. It's like everything else seems to work fine. It's just the movement speed. But okay, I want to test this now. So if we go back, if we go up to the thing. Oh. Oh, sorry, you can't see that. Why is it not showing up? There we go. Yeah, I don't know if you saw it, but I should really add like a debug heal or guard mode or something. Oh my god. It's actually harder now when you move faster. Oh my god. Why didn't it spawn earlier? Okay. Just joined. Yo Ian, how are you making the levels? I actually made my own editor to do that. In Raylib and imgui. Whoops. And Zig. Let's see. Why is this guy not spawning here? That's so weird. Yeah, you're not supposed to run this fast. I'm gonna have to check the... Because it's not the physics that's the issue, I don't think. It's probably... yeah, I'll have to check it out. Because the jumping seems to be the same. It's just the movement speed that changed. Yeah, and now there's no issue because we've kind of... Okay, so I think that's... Wow. Let's go back to 100. And try again. Yeah. I have to check that out. Like, why is the movement speed changing so much? That's strange. up here. And yeah, now it starts to lag. Okay, let's see if we can fix that catch-up issue. I want to see what is this really saying here. Max fixed updates per frame set to 10. So after that, I guess we say that, well, then time is like slowed down or something like that. And then times second per frame. Whatever is like the minimum. So essentially, if dt becomes larger than this, then this would be the simulated dt we're trying to reach, and then we're gonna get stuck. So I think that's the issue. It's like, because dt will grow if the physics now all of a sudden takes longer, dt will grow, and at some point it will like surpass this here, at which point we're always going to take this amount of time because the dt grew to that, so the frames took that long to get finished, so this will be how much time we need to simulate. But that seems wrong now. I think it's essentially what we need to simulate, the seconds per frame, right? Isn't that what we need to simulate? That's the max. I mean, yeah, I think if we get rid of this, or we just set this to 1. So dt is going to grow to seconds per frame, and then essentially one physics update is taking up the whole real estate. But that's fine. All right, let's see here again. Well, okay, I can explain a little bit more on the levels there, because I mean, it's essentially, it's only like a bunch of JSON files. Like that's so the game is kind of like, it's a combination of these JSON files that defines things like animations, textures, other things like entity types are also described with those JSON files, like and the JSON files are basically exported from the editor. So you can define a bunch of things in the editor and then export them, and the game program will then read in those. So it's kind of like a mishmash a little bit. Okay, so it goes down to 50 FPS and it slows down now instead of just dying. So I think this is more better maybe. And that goes up. And now we're essentially back. Okay. So now maybe we can, so actually, okay, so we want to calculate this. If we want 100 FPS, each frame only should take 1 or 10 milliseconds, which means when the physics updates takes like 8 or 9, it takes like almost all the real estate of the update function. So, of the frame, the whole frame. So, okay. But I guess this is better. But there is some still some performance issues there. Okay. But yeah, I think this is gonna be it for this time. But yeah, I think we made a lot of progress. I mean, we got Tracy working a little bit better. We got the collision code working again, and it seems to be a little bit better with the thread sporting. We could try to optimize a little bit more. I mean, I don't think we actually optimized too much, to be honest, right now. It seems like spawning the threads takes like just as long as running the actual calculation. Almost like, so we don't really gain that much from this thing here. I would say, well, from the initial like measurements that we saw anyway. So maybe we could try and do this differently. I'm not sure, but yeah, we'll see how we can deal with this. I can also do a little bit of research on things like the quad tree and having collision groups and all that as well, and see if I can improve on this a little bit more. But yeah, so that's gonna be it for this time. I'll see you probably tomorrow, and hope you have a nice day, and I'll see you later. Bye bye.